Okay, for people joining this live stream, we are looking at what I think or hope is going to be a fairly straightforward piece of Wolfram language design to do with our hash function. All right, so we have been using strings to represent different kinds of hash codes. And there are famous ones like SHA-256 and so on, right? Which are conveniently stringified. Okay, but so
there are hashes with variable length size. Therefore, we cannot just come up with a number of strings.
I understand. So the obvious thing to do is to have the full specification be an association and the strings just be shorthands for particular associations.
Yeah.
Okay. And why do we need any of this? Why do we need?
So perhaps we can look at the second part with MAC authentication code below first. All right. So the difference from hash is that it has a key, which is a part of an argument. And since it's not evaluated, it can be carried, and hash cannot.
That's why... Okay, hold on. The reason hash cannot be carried is because it has a default case, right?
Okay. Because it eats anything.
I know, but it has a default one argument form that means use the default hash code on an arbitrary expression.
Yes.
Right?
Yeah.
Okay. So one issue is, can we have something which is a curryable version of hash, which simply takes the type and that can be curry applied, so to speak, curryably applied. Okay, so let's look at this method authentication code. All right, so what's the difference between this and a digital signature?
A digital signature is mostly for to authenticate the party that is signing, and message authentication code is more to authenticate the data, though they are pretty similar.
Okay, so now we've also, in addition to hash, we've got file hash, right?
Yeah.
Okay, so a curried form of hash will be confusing with respect to file hash because we don't want a curried form of file hash as well. Okay, so we have to start thinking about those kinds of issues, right? Okay, so let's understand. So let me look at, okay, generate digital signature for an expression with a key. Okay, now that has a curried form. Generate digital signature has a curried form, right? Yes? And this, okay, so unlike a hash, which we are simply representing as a byte array, is that true? What are we representing all those various hashes as?
We can create different forms, but it's a number or a string.
I'm asking, what does hash do? Okay, right now, if I say hash of blah, 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 I'll just get a number, right? Okay, so now if I say hash of that, comma, SHA-256, I get, what is that? Is that a number again?
Yeah, still a number, always.
Okay, so now, when people give hashes out in the wild, they usually won't give them as decimal numbers, correct? The typical way a hash is presented is as a hex string. Am I correct or am I not correct?
Yeah, but that's the third argument, like the other argument of hash. So that's like already there.
Okay, all right, so let's take a look at that. Okay, so what is that? Can it say hex string? Yes, it can. Okay. So that's okay, fine. So even if we were currying, okay, we've got a problem here because, okay, so problems with currying. Operator form problems. Okay, we've got a problem with file hash. We've got a problem with the third arg. Okay, and we got a problem that it already has a one argument form, but that's a less serious problem than some of the other ones. Where should we put this? I guess this is an ILD derived meeting. Okay. Okay. So, all right, now I want to understand generate digital signature always takes a key, as message authentication code also always takes a key, correct?
Yes.
Ah.
It cannot derive the key from the string. You would have to do like generate estimate. Private key.
Okay. All right. So now what will message authentication code return?
It is essentially a hash. So by adding key, we just prevent anybody calculating the hash.
So it's like salt.
Salt is a public thing, and that is a private. Yeah.
So wait a second. So the authentication, remind me what this is used for, the message authentication code.
It's when you want to verify that the data is correct, but you don't want anybody, just arbitrary person, to check that. Only the person who has the key.
Okay, but so explain the protocol to me, how it's used in practice. So in other words, in the case of digital signature, you've got an asymmetric key pair. In this case, what do you have? Just explain to me how this is actually used. What is this actually used for? If I send encrypted email, am I using these things or what? Hello, can you tell me what this is used for? Just tell me a use case.
It's used for authenticated encryption. So you would calculate this before encrypting the message with the symmetric key with which you're going to be encrypting your message. And then you attach that to the message, and then you encrypt that same the message, and then you send them both to the receiver, who is the only person who is able to verify this hash authenticated message authenticated code, and is the only person who is able to decrypt your message as well. So it's kind of a symmetric analog of digital signature, if you wish.
Okay. But you are returning something which isn't a digital signature-like object, right? You're returning just a naked string or hash code, correct? From message authentication code. Is that the idea?
Yeah, you return the same as a hash. Yeah, just a number.
Okay, but you got to be very, very careful here, because digital signature returns an object that knows it's a digital signature. Okay, you are proposing that message authentication code just return a naked number or string, correct? Is that correct?
Yes.
Okay, so is that the right thing? Because, okay, why is digital signature? You know, digital signature could also perfectly well just be some byte array down here, except that it is useful to store information about, you know, this metadata about what kind of a digital signature it was, right? Am I making sense?
Yes, because you need that to verify the signature.
I know that. So don't you need that same type of information to verify the message authentication code? The answer is obviously yes.
Yes, you might.
The answer is obviously yes. Right? So, because what you want to be able to do is here, we want to be able to say verify digital signature, okay, of whatever it is with the key, right? With the private, whatever it was, whichever one I didn't use, public key or whatever, right? Correct?
Yeah,
Is that
this way
correct?
you don't have to specify any options. It's for the same logic why encrypted object was used, because you have this metadata and then the decrypt function doesn't have to have any options because all the metadata is carried over in the encrypted object.
Exactly, right. All you have to give is the key, correct?
Mhm.
Well,
that
the
correct?
key, and for digital signature, also the original message for which you're trying to verify the signature.
Okay, fine. All right, so let's walk through the same workflow for message authentication code. Okay, ready? Yes?
Mhm.
Okay, so just like you say generate digital signature, right? You might say generate message authentication code. Bit long, but okay, let's just write this out for now. And presumably, you see, no. Okay. No, this isn't properly thought out. Okay, look. Generate digital signature can take a pure key, right? A one argument form.
Mhm.
Okay, so the way it works is it's packaging the hashing method into that one argument form. So in other words, this has to have either the form where it says key that's applied to an expert, or it has to have, just like this one, an expert comma key form. Okay, now you're going to say, but what about the method? Well, obviously, just like with this one, which presumably has multiple methods as well, does it not?
Mhm.
Right. That's the method must be packaged in with the key. Am I making sense?
No, it has a default kind of. So what is packaged into the key is like the algorithm, whether it's RSA or elliptic curve, for example, because the key is completely different. But things like hashing function that is used and is like something that is in like a default thingy.
Yeah, it's fine. It's fine. Usually it will be a
No,
default, but the point is, if you just type in here, if you say generate message authentication code of of hello, right? That will use a default. That will use defaults for everything, and that key. Is that right? So it's like HMAC SHA-256 or something, right? Is that right? Let me just explain. I don't know whether you guys have thought this far
You
forward.
have to specify. You have to specify the algorithm. You cannot.
Why? What's the default algorithm?
There's no
Okay,
default.
listen,
I would
guys.
say
Look, I'm
yes.
sorry. This is what I get for having done language design for 40 years, is that I can plainly see you are going to head for a cliff here in the way that the currying works for this, okay? You won't be able to get that to work. You've either got to have the one argument form, okay, that packages the key and the method, right? As soon as you don't have that, as soon as you have the method exposed, you can't make that unambiguous relative to the two argument form that has the expert in it, okay?
You don't package the method into the key. So in the last, when you highlight it, can you insert open and close square bracket after the code directly? So there are two. Yeah, so
No, you're saying
that's why you package.
no. Look. Are you saying, okay, look, we could probably get away with something where we say key, comma, method, arrow, whatever. Do you see what I'm saying? You cannot get away with something where you have a two argument form where the expert is an arbitrary expert. You see, but the two argument form would have to be the thing, just like digital signature, where there's an arbitrary expert followed by some key specification.
But for message authentication codes, it's like the most common, how do you say, the standard is that the key is just a byte array, can be arbitrary byte array. So it's not really a thing that is different. Like for RSA, we need an object for like private key and public key because different algorithms use something completely different for a key. For message authentication code, it's like always a byte array or well, a string.
Okay, okay, that's fine. That's fine. So what's the issue? So the issue is you say you can't, okay, the question is there a default message authentication code algorithm? Yes or no?
No.
Really? Why not?
Well, because they didn't settle on one. There are a number of things that are used. There is no way. There is no preferred choice. HMAC is probably one of the most popular, but
all right. So there's no default. So you're saying
no default.
There's no default.
Mm-hmm. Yeah. Another thing is that it is a function of 2 arguments. You should not pack into key anything. It should be just a string or a byte array.
One of the reasons
these
why
are alternatives up here. Are
yeah.
these alternatives?
Yeah.
Okay.
One of the reasons why we got into this message authentication code thing is that, like, if you look like on top of the notebook, the agenda notebook, on top of what you had already, for generate digital signature, if you for hash to specify all those things about length of the key and length of the output, you just use a method. When you try to give that to generate digital signature, you got a double level included a nested association. There was one of the reasons.
Wait a minute. I understand. I see that. But so this is currently supported, correct?
When the method is just a string,
no.
If you specify it as a string, it should be supported.
No, I'm sorry. For generate digital signature, you're saying right now the method allows a hashing method, but the hashing method is just a string. But as soon as we allow the hashing method to be specified by an association, that will be able to go one level down and have another level of association, correct?
Yes.
Yeah.
Okay, I don't think there's a problem with that. Do you think there's a problem with that?
No, I don't see a problem with that. This is the proposal, actually.
Okay.
Well, there was one of the things that were proposed also to have like a hash algorithm head to kind of package it a little more readable, but it's just aesthetic. It would still be an association inside.
What's the proposal?
If you scroll up, there is possible proposal.
But by the way, could whoever's like moving around or doing something, could you like not do that or put yourself on mute or something? So okay, go ahead, please.
Yeah. So proposal highlighted, and below that, the second bullet point, possible proposal. Just below.
Okay. So that's introducing a new thing called hash algorithm, which I don't really believe in. I don't understand the point, other than that we're getting ourselves out of the box of the fact that we can't carry hash.
Yeah, it just packages the whole thing into.
I know, but we don't have an analog of that in all these other cases.
No.
Okay, so I mean, I think the way we might be able to get out of this is, but it's going to be a mess because we've also got file hash to think about. So I'm saying
so hash algorithm actually packages all the stuff, and it is a one argument function. So if we stick it in, it's like
I know, but it can't do it with files, right?
We can put it in the file hash in where we use a string to specify the hash.
Yeah, in the same place, like in hash.
Yeah.
So this whole design is about the string which we specify the hash. So whenever we use it, we should be able to use the new design.
I know. All right. So the thing is, in what we've done in cryptography, we do not have a disembodied algorithm wrapper. Do you understand what I'm saying? What we do instead is we say things like generate, the algorithm itself is packaged into the use of the algorithm.
Yeah, it's more complicated level because, to make sure that every piece is stitched correctly.
Okay, so, the analog would be here that the thing we return will be some kind of hash object, but we don't think we need that.
Yeah.
Right, we don't think we need that, but that will be the analog of what we're, okay.
Yeah,
So first is, so the first issue is we would like something. The first thing we're trying to get here is we'd like a curryable form of hash. Is that correct? That's the main issue up here.
No, first thing we want to package parameters into hash specifications.
I know that. I know that. We've agreed how to do that. We know we're going to have an association, which is an alternative to the string. That's done. We're there with that. Okay. And maybe there are some elided forms like this. Okay. But the fundamental main specification would be an association. Make sense?
Okay. Yeah.
Okay. So we're agreed on that. Now, the next question is there a curryable form of hash? Okay. That's the next thing you're trying to address, correct? Okay. And we don't have a good solution for that because hash itself obviously has a default one argument form. Okay.
Yes.
Okay. So that's the issue we have there.
Compared to digital signature, to verify digital signature, we need meta information. And for hash, we don't.
Well, once you've got the hash, it's just like, here it is, be happy. It's a random string. It's a random number, whatever. Okay. Now, I mean, Look, there are a couple of things going on here. I mean, first point is that returning a hash as a number, while convenient for random non-cryptographic and so on uses of hashing, is bizarre from the point of view of people, doing file hashes and things like this.
Yeah.
Okay. So like for cryptography, we always use the byte array as a third thingy inside for calculations. And then for people who are doing like file hash, it's usually a hex string because you just send that as a string.
Right. But listen, I've used hash a zillion times where I literally take, I'll take, I'll do things like I'll say mod hash, 100 or something. And, which I'm doing for just, some totally random, thing where I just want to be able to distinguish them. Am I making sense? So
So there are two different types of hash in terms of, users.
I know, cryptographically secure hashes and non-cryptographic.
So what you are after is a very quick hash. It's okay if it's a hash.
I know, whereas some people want cryptographically secure hashes like SHA-256.
Exactly, yes, yeah.
I understand. Which gives us a certain possibility, okay? That we could conceivably have a function called something like cryptographic hash that works in a different way than our just El Cheapo hash function, possibly.
Or secure hash, probably.
Maybe, yeah, maybe a better name.
Because we don't use cryptographic anywhere.
Okay. I don't really like using secure because that's kind of signing up for the fact that, it'll never be broken, even in the world of whatever. But okay, but in any case, we may have a little bit of wiggle room there. Okay, because I agree with you that there are different uses, and
I honestly think that introducing another function that does hashes, but just like slightly different, is an overkill.
Well,
For this way,
that's
we
what
would
that's
have
what
to
you're.
have like
No, but
secure encrypt and remove this out of there. I don't know.
no. That's not the point. That's not. But so that's the bad word, right? That's the wrong word. But this is not a good idea because this would lead one to have crypto algorithm, digital signature algorithm, et cetera, et cetera, et cetera. You see what I'm saying?
Mhm.
That's wagging an even bigger dog. Does that make sense? I mean, so we need a way. Look, we've got a problem. We've got a little bit of a design glitch here with hash. There's not a stupid design that we had. That the fact there's a one argument form of hash is completely sensible, right? It's just that we're now being bitten
Mhm.
by a feature of that. Okay. Okay.
Mhm.
So again, all of this stuff is fine, right? And I don't think there's a problem in the nested associations here. Does anybody think there's a problem with these?
No, I think that's fine.
Okay. So, okay. All right. So now let's go back down. All right. So why did we want to introduce this hash algorithm thing again? Oh, because we want a curried form of hash.
It's just a wild idea. We may just drop it.
Okay. But I mean, the thing that is, okay, our other functions like encrypt and so on, doesn't encrypt has a curried form, right? Is that true?
I don't remember.
No, it does not have a curried form. Well, I'm not buying hash needing a curried form.
Mhm.
Okay. So let's come down here. And okay, if we don't worry about a curried form here.
Mhm. So then it's just export key, and then it's basically the same as hash, but it takes two arguments in the front.
Right. And it has no default, so it has only a 3-argument form.
Mm-hmm. Or 4.
What's the 4 arguments?
Like hash, so do you want a number or a string by time?
Okay. But those arguments, in principle, many of those arguments could be packaged together in association. Is that a true statement or not?
Like the third argument of hash can be like format goes to hex string.
I'm sorry, it can be what? So just say that again, Daria. The third argument, what?
The third argument of hash that is hex string can be just a part of method that says format goes to hex string.
Okay, that's okay, fine. So in other words, you're saying that in hash, there isn't strictly a need. By the time you've got an association as the second argument, you don't actually need the third argument, correct? In that case. That's what Daria is saying. Daria is saying that one of the elements in the association can be output format.
I don't like that because calculating the hash and specifying the format, the output format, they're different.
Well, I don't think it matters. So look, do you understand? I'm not suggesting that we remove the 3-argument form of hash. I'm only suggesting, and Daria is suggesting, that it be possible to package together, which I think is a good idea, because you can pick it up, and then you've got the equivalent of the curried form of hash. Okay, you've got something which is sort of almost as convenient in the sense that you're picking up this association, you're just sticking it in hash, and then it does the correct form of hashing. See what I'm saying? Yeah. I think it's a perfectly reasonable idea.
Putting the return type into what is otherwise purely a specification about parameters of the algorithm just so that we can get a curried form. Seems like
No,
a bad trade-off.
you were not paying attention. You were not listening.
I thought I was paying attention, Stephen. I thought I said that accurately. You were saying that you're talking about putting the return type hex string into the association that describes the hash algorithm.
Yeah, that's...
And Constantine is saying he doesn't like that, and I agree with that. It doesn't belong in that.
Okay, but it has nothing to do with currying.
Well, I thought that you were saying the only reason to. I thought that you were getting this last argument out of hash hex string so that you could curry it. I thought that
No, I was saying it is the moral equivalent of currying because it allows you to have something which you can pick up as a single argument and say, this is my...
Right, the moral equivalent of currying, fine. But I agree with Constantine that it doesn't belong in that association. That association, which is used in other places where it wouldn't even make sense to specify a return type.
All right,
that
okay,
association.
Yeah, okay, that's true.
Okay.
Yeah.
All right, okay. Okay, so let's come back down here. And so you're saying there's a 4-argument version of this. Expa key. So now notice that encrypt has the key first.
Yeah, it could be first. I don't insist. Yeah, that should be consistent.
Okay. Now, in the case of really? It's not examples of this. Where's this? Oh, I see. That's in the method association. Okay. So in the case of encrypt, all of the detail about how it works is in the method because there is a default encryption. Right?
Yeah.
Yes.
We just picked one.
Okay, but here you do not want to do that. So the likelihood is it's going to be message authentication code of key, comma, expa. Yes?
We could have the third argument, which is algorithm specification as automatic, and we could just assign something to it. But
well, the alternative would be, okay, that first form, which we would now have as that would now be key expa. We do have it always that way around. It's always key first for all our functions. Is that correct? Digital signature works that way as well. Is that correct?
I think for signature, it's actually the other way around.
Okay, so then why?
Yeah.
That's an interesting question.
And then it has a curried form. Okay, so we could have it be the other way around, probably. Okay, well, what makes more sense? If you were reading this off, what would you say? What would the sentence say that describes what this is doing?
The expert would be first because it's the message you are authenticating.
Well, like with digital signature, is that right?
Yeah.
So, but I'm asking, what sentence would you say? You're saying, I'm generating the message authentication code for expa using the key. Is that correct?
Yeah.
I'm asking, what is the sentence that you would use to describe this operation? Is that
that's what you said. That's correct.
Okay. And similarly, you would mostly say here, okay, for expa using the specified private key. So in this case, it's generating message authentication code for expa using the specified key. Okay. And for right now, we would only support a 3-argument form in which there is an explicit message, explicit method specification, which can either be a string with a bunch of defaults, or it can be an association. Is that correct? Okay. And by default, this thing will return a hex string or what? Or a byte array? What will it return by default if you don't give a 4th argument?
Yeah, I hate to say, but it should be consistent with hash. So it should return a number, an integer, even though.
Really? Really? Really?
Yeah, it's not a good idea, but it should be consistent with
Well,
hash.
I don't agree with you. I don't agree with you. I don't think it needs to be. Hash is a function that has a 1-argument form. Okay, that has, I mean, what would be the most useful thing for message authentication code to return?
I would say byte array.
It's a byte array, yeah.
And what function will you use it in?
Usually you package it together with the message.
How?
Basically to store.
How? I don't understand why we don't have this return an authenticated message, for example. I don't know what the right name is, but something like this, which has the message in it and the code. And then if you want to verify it, how would you verify it? Let's imagine that we had, just like generate digital signature, we have a thing like this, except that with digital signature, it's just a disembodied signature, whereas here it would be the authenticated message with its code.
If you want to verify it, you extract the message from this thing and apply message authentication code again.
With the same key, like with the hash.
Yeah.
With the same key.
If
right.
Yeah, with the same key. So
okay,
if you package it, then you will have to extract the message.
No, Konstantin. Think about it, right? Think about it. Okay. The problem is that expa right now can be an arbitrary expa, right? Okay. So, although we might be able to get away with having it be an arbitrary expa, except for one with head authenticated message. Okay, but then this is what you would want, presumably. No, you would have a thing that is called verify. Verify authenticated message, basically. Correct? Right, given the key. Just like we have here, verify digital signature with the key, correct?
I think it can be easier and be more close to hash, like really.
So message authentication code should return something we can stick back as a first argument into it. Oh, no.
Like you do with the hash, you calculate the hash of expression again, and you just compare the output with what you got.
Yeah.
Verified digital signature is different because verification algorithm is different than signing algorithm. For hashes.
Okay. So what you're saying is
it's one way.
The problem is, let's think about this in practice. Okay. What you want to do, let's think how people will use this, right? So for example, they might want something in a notebook, which is somehow, well, I don't know. I mean, I wish you could. Is there any way you can not have this background noise? Sorry, I'm just. Okay. So, all right. I'm asking you. You've got the message. You've got the code. Now you send both of those, but how do you send them? In what form would you send them? Would you send them as a list, as we're doing here, message, signature? Do you see what I'm asking?
Yeah, they don't have to be attached in some special way.
I know they don't have to be. I'm asking, in the actual practical usage, what would you do? You could write the code on a piece of paper and stick it on a bulletin board, but that's probably not what you're actually going to do, right? I'm asking, in practice, how will people package these and move them around? Did you understand my question?
Yeah.
Okay, so what's the answer? Give me a use case for all of this, right? I've got a big file. I mean, I don't even know what the file version of this looks like. What does the file version of this look like? I've got a file. I want to be able to have, I mean, I've got my email message or whatever, okay? And I'm going to send it with some kind of code, right?
Mhm. So you just stick just append as a separate part, you send the message.
Append as a separate what?
When you send an email, it's just separate, it goes as a separate part.
Yes, I know. It goes in. Okay, it's effectively an association where part of it is the text of the message, part is the subject line, part is this authentication code, right? What is the interoperability of this stuff with our email handling stuff? Do you understand the question?
Yeah, so since this is a new function,
Well, assume that you want to send verified email. You would be using one of these, is that correct? Or is that not correct? I thought actually with verified email, I thought you picked up people's public
you would
keys.
sign, yeah, you would sign it.
Okay, so that's not relevant to verified email. Is that true? Or is that not true? Todd, help us out here. We're drowning here.
Well,
I don't
unfortunately,
think
my
we were
knowledge of
like even
cryptography is quite
supposed to get
limited.
into message authentication code anyway. Like, I don't think this is a function that we're going to add in this new version, Konstantin, right? This is just like one of to support the things that we need more flexibility into hash because there are more uses to that. But we're not actually trying to design this function right now.
Well, but we might as well design it since we're doing this, you know. Okay, can we please just clarify, please? This is not used for verified email. Yes or no? Is this used for verified email?
Not for emails, no.
Okay, so what is it used for?
For example, so when I calculate hash of file,
Of what?
I'm sending you a file and I'm sending you a hash, or you get the hash to verify that the file is correct. So I don't want anybody to forge the hash. So I calculate message authentication code, and I use the key which we share. So in other words,
No. I mean, but look, this is a case where you assume there's a secure channel for the key. Is that correct?
Yeah.
Okay, but there is an insecure channel.
You should have exchanged it beforehand.
Right. So as opposed to the public key case, where you can send something which can be verified only by the receiver from their private key because they publish their public key but the advantage here, well, I don't really know what the advantage here is because the sender and receiver have to have agreed on the key, correct?
Yeah, pretty much. Yeah.
Okay. So in practice, like when people use a checksum for a file, for example, or a hash for a file, what's the difference? I don't even know now technically. I'm confused what the technical difference is. Okay, what else are we doing in addition to just hashing the file? We've got a hash of the file. What is this HMAC part of it doing? That's some kind of key derivation function, isn't it? What does HMAC do on top of the SHA-256?
It calculates SHA and combines it in a way that it cannot be forged. So
or only that combines it with what?
It prefixes with
the key.
With specific things, and then calculates hash again. It's
okay, but so when you say it can't be forged, you're saying, I mean, it is the case that given that key, I can go back to the message and I can regenerate whatever that MAC code is, right?
As long as you have as the message and the key, yes.
Right. Okay. So could you explain again, what does the HMAC part of this do? So I can generate the hash from the expert and the key. I can generate. Oh, I see. I see. I see. I see.
So,
The difference. No. I get the point. The point is that the hash is generated purely from the expert. There's no key involved. What the
Yes.
HMAC part of it is doing is tangling the key up with that hash.
Exactly. Yeah. Mhm.
Okay. Okay, I get it. Okay. Okay. Well, and your contention is that in practical uses of this, that I would have on a separate channel, I would send the key information. So that the only thing you're sending is, well, you're sending the message and you're sending this message authentication code. Is that right?
Mhm.
It's like the same workflow, like you would send an encrypted message, only that this encrypted message can also be checked for data integrity, like with hash, but like tangled into the key.
Oh, sorry. So that but why isn't a digital signature doing the same thing? But this is the symmetric
Because
key
this is
case.
a symmetric, yes.
Okay. So this is the symmetric key case of digital signature, basically. Am I right?
Yeah, more or less. So for you use like public key channels, like key exchange channels, like TLS does with public keys to exchange the symmetric key. And then you use this symmetric key to encrypt your message, but also to calculate a message authentication code that is like allows you to check the integrity of the message upon receival.
Okay. So let me ask a slightly more radical question. Could we in principle use generate digital signature? In other words, if this was known to be an HMAC method, would the workflow of generate digital signature, verify digital signature, would that in fact work? Surely it would.
Yeah, it would. Yeah.
But then people would not really understand it. Like they would look for MAC and they would not be able to find it in our documentation because we package this as digital signature.
I mean, that's a detail about how, but I'm just trying to understand the workflow, okay? The workflow is identical to generate digital signature, correct? Except that when I generate the digital signature, instead of providing a private key here, I provide a symmetric key.
Mhm.
Well, some digital signature algorithms use HMAC on the inside, so I think it gets too confusing at this point.
I understand, but the thing we want to do is to make a workflow that is, maybe it has a different name, but it is the same workflow. So for example, if we say, for example, let's imagine that we say, generate, let's imagine that this was, I mean, we can't really call it, that would be a silly name because it repeats the word code. But you see what I'm saying? I mean, would it be called a MAC signature, or is it always just called a code?
It's just called a MAC.
Okay, well, so let's imagine that we had something which was generate MAC, which is what you're calling message authentication code here. And it takes the message and the key, identical to generate digital signature, right? And then it takes...
I think it should be more closer to hash, like honestly. It should be simpler to generate digital signature workflow that we have. It's more closer to hash because you calculate the hash and to verify it, you do same queue.
Okay, but then hash is giving the method as an argument, but digital signature is giving the method as an option, correct? That's the difference, right? You agree?
Yep.
Okay, so, but the point you're making here is there is no good default MAC method. Am I correct?
Mhm. Actually, so another name for this is keyed hash.
I think that's
Yeah,
obscure.
but the difference, it's
That's obscure.
okay.
I mean, I think it's less obscure in terms of what it does. Conceptually, it's more obscure in terms of its common usage.
Yeah, basically the usage of the signature is like a digital signature, but yeah. So
Okay, all right. So again, okay. So I would think that what is the most useful form of message authentication code? You think it's a byte array. Why isn't it hex string? Because the hex string is more exportable than a byte array.
Can be a hex string, yeah. Fine with that.
Okay. But I don't think it has to be the same. I'm sorry?
yeah, I prefer byte array because it may contain non-printable characters. So string.
Well, a hex string doesn't contain non-printable characters.
Okay, yeah. Right.
Okay. So what we're saying is the default would look like this. It'd be a 3-argument function that would by default return a hex string. And like hash, its 3rd argument could break into an association. And like hash, it would have a 4th argument that gives the format of the return. Is that correct?
Yeah.
Okay. Looks good to me. Any objection to this design? Which is very close to the design you originally proposed. Any objection to this design? We do not get a curried form at this time.
I'm fine with not having a curried form.
Okay.
Yeah, agree.
Yeah.
Okay, so reviewing then. So this is one thing. We'll make a bright yellow background color here. Okay, we've agreed on this. And we've agreed on the breaking of on this turning into an association. No, I'm sorry. With the no.
Yeah, with the hashes.
Okay, but the hashing method would be the same association that occurs in the 2nd argument of hash.
Yes.
Correct?
Should be, yes.
Yeah.
Okay, looks good to me.
What about the string pair form of a name and bit length?
I already said yes. I think it's fine.
Right,
Yeah, I think it's fine. I think this is fine.
Slightly marginal because it assumes that the 2nd argument is a length, but
Is it what?
we want to have something else. So second element of the list is the size, is a bit size.
No, it doesn't assume that. It assumes that whatever the 1st argument is, whatever the 1st element of that list is, determines the form of that list. So if you need
Okay.
It doesn't matter. It should probably be conventionally a length.
Okay, yeah, that's fine.
Now I don't know what happens if I say SHA-257.
You should get an error, but if the hash algorithm allows that, then you'll get the result.
I understand. I'm asking in practice for SHA, there are just a limited collection of SHA algorithms that are defined, correct?
Yeah.
Okay. Is there anything that has a continuous value, continuous thing defined, except maybe our default hash function, which can be modern?
Blake can have any multiple of 8, more or less.
Okay, fine.
Yeah, and there are others.
Okay. Looks good to me. I mean, can we get this message authentication code into 13.1?
Yeah, we might try. Not for all algorithms, of course, but at least one.
Just in terms of the name, I mean, HMAC seems to be, I mean, this is a hash-based message authentication code, isn't it?
So there was CMAC and now HMAC, but now they came up with Black 2, which works differently and it's preferable, but they didn't settle on that.
Okay, all right. I'm just clarifying the name, message authentication code, is the right name.
We may want to have a wrapper or not.
No, there are no wrappers. There's one name. We're getting one name here. No wrappers, one name.
Okay.
Why is there a wrapper?
No, I meant that later we may decide that hash should be not an integer but some object. But then unfortunately we already used message authentication code for a function, something like that. But unlikely, but
I see. I understand what you're saying. Right. So the return value would be that we would want a return value like digital signature.
Yeah.
So it should be called generate message authentication code.
I'm kind of thinking it should be. Yeah, that's what I proposed earlier.
Message authenticate.
No, because it's not authenticating the message. It's just generating a code.
Yeah, sure.
Actually, keyed hash is quite a popular and understood name, but you may not like it. But if you say keyed hash, I mean, understand.
Well, I mean, keyed hash is nice in terms of it being more general. I worry about the name message because it's like, well, it isn't a message; it's a piece of data. You know, it's a biometric signature. It's a whatever. Not a message. You get what I'm saying?
Message authentication code actually indicates the use, but in fact, it is a keyed hash. So if you,
I mean, I like that. I think that's a better. I mean, in terms of being able to find MAC, if people look up, so long as we have reasonable search in the documentation, if you look up MAC or HMAC or CMAC or whatever else it is, that should lead you immediately to keyed hash. Well, I mean, keyed hash
are the usages of keyed hash.
Right. So an interesting question for keyed hash, given its name, is whether it is EXPA first, key second, or whether it is key first and EXPA second. Do you see what I'm saying?
We can try to see what it's more standard for, for having this function.
Fine. I would tend to think, given the name keyed hash, that the key should come first.
Could be, yeah.
Because it's saying, it's all about keying. That's why it's got the name keyed hash. All right. Look, keyed hash is a good idea. It's a better name.
And do you think it should return? You're still going to have it return a hex string and not some sort of object?
Yes. There's no reason for it to return an object. It's not
not an integer.
I'm wondering about that.
Yeah, I had to bring that up, but I don't like the integer as output, but yeah, well, here we go.
I think we can get away with returning a hex string because I think that the use case here is so. Look, hash has a use case. Oh, by the way, it'll never be in this form. It'll always be key EXPA method, right?
Yeah.
And we can kind of make the claim that there's we can't really make the claim. We should have made the convention that hash, if you give an explicit method, returns a hex string. but we didn't do that. I think it is pointless to return an integer here.
Okay.
Do you agree? Like, that's never what people are going to want.
Yeah, okay. Mhm.
All right, this looks good. Okay. Wasn't quite as simple as one might have hoped, but
Is it ever?
is it ever, right? I know these are always complicated. That's why, and the trick is to not make a mistake.
Right.
All right, we'll see it again when it's implemented. And okay, anything else to talk about here? Nope. Okay.
Oh,
Thanks a
so-
lot.